Hi, my name's David Bolton, and this is the first of a series of videos that I'm doing in order to explain some very basic knowledge of the astronomy and the geography of astrology. More often than not, astrologers limit themselves to using the standard natal chart, an example of which you're viewing right now. That's my chart, as a matter of fact. However, by only using this type of chart, we're losing sight of exactly what the relationships are in space between the planets and the axes of the chart. After all, this chart, and normal astrological charts in general, are always in two dimensions. Well, you do them on paper on the computer screen. But in reality, of course, the Earth and its motion in relation to the Sun, Moon, and planets, that all takes place in 3D space. So my goal here is to show you how to understand an astrological chart in 3 dimensions. In so doing, you'll begin to understand, for example, how house systems were developed, also why many house systems fail at extreme latitudes, and even totally collapse. As this video series progresses, you'll get an introduction to little-known techniques, and some that are entirely new, and all of which are based on sound astronomy. In this first video, though, I'm purposely going to limit myself to something that, that many of you will probably be familiar with, but others might not be. And that is something as simple as the geography of the Earth and how to measure longitude and latitude. Now, you can get the Omnicycles program that you see here at our site. I'll show you at the end how to go about doing that. For now, though, let's look at Google Earth. Now, if you don't have Google Earth already, I suggest you get it immediately. It is a free program now for over a year now, about a year and a half, I believe. Google has been offering the pro version even for free. And you simply must get this program, find it, Google it, download it, install it. We see an example on the screen right now. Now I'm going to deactivate some of the things I have activated here that pertain to my own chart. Let's see here. Oh, just a second. You see here at the left how you can open or close things. You won't see these things when you first install Google Earth. These are additions made with the help of the Omnicycles program that we're going to be getting into then. Just a second. I'm going to keep deactivating. Okay, now we see what you're going to see when you first install Google Earth. You can make the Earth bigger or smaller. You can even get right down to see places in detail, cities and the like. You can zoom in here. This is Spain, for example. And, well, here we're out in the country somewhere. It looks like olive trees. But you can find cities where you've lived or places you'd like to visit in the future. But the subject here is longitude and latitude. Okay, what are we going to do? Well, first we're going to zoom out. And we're going to put in some lines. Up here, view, grid. There we go. We're going to make the Earth upright by moving this to the top. Here you see the equator. Now, the equator is what we call a great circle. A great circle is defined as a plane that divides a sphere, as is the Earth more or less, into 2 equal parts. In other words, the diameter of a great circle is going to be the same as the diameter of the sphere. I'm going to close my window here because there's a plane flying overhead. It's a bit noisy. Okay. So this is one great circle. Here we would have, for example, another great circle. This is the prime meridian that goes through Greenwich, England. And this divides the Earth into a western half and an eastern half. We're going to be dealing a lot with great circles in this series. They also have astrological significance, not only astronomical or geographical. But just so you know what a great circle is, it's a plane that divides a sphere into 2 equal halves. Here we have some circles, but they're not great circles because if we cut the Earth into 2 parts here, we would have a small part and a large part, so that's not a great circle. We must be able to divide the Earth, no matter which way that great circle goes, to divide the Earth into 2 parts. Now, as far as longitude and latitude are concerned, latitude is measured north and south of the equator. Here we see N10, that's 10 degrees north. As you probably already know, the circle has 360 degrees. The sphere will have 360 degrees. So if we follow the equator, move the Earth around here, we see eastern, east 50, east 70, east 90, east 110, 30. Then we come to east 180. That's half of the Earth, right? Once we get to east 180, it starts going backwards. Then we're in the western part, western hemisphere, and it starts going backwards from 180. In other words, 180 degrees east, this is longitude I'm talking about here. Longitude is the east-west measurement of the Earth. Once we get to 180 degrees east, the 180 degree line is at the same time 180 degrees west and east. So we go all the way up here east 180, that's the same as west 180, and then we start counting backwards. West 179, 178 west, etc. Here's 170, 130 west, 90 west, until we come all the way back to the prime meridian that runs through Greenwich. Why does it run through Greenwich, England? Well, that's a convention. It was decided in the late 19th century, though France didn't accept it till after the turn of the 20th century. They wanted that meridian to run through Paris, of course. But since the rest of the world had accepted the Greenwich line, France decided to as well, sometime in the early 20th century, as I said. So, latitude measures north and south. What's the convention there? Well, that's obvious. That's the equator, right? The equator being this great circle, and the equator having two poles. Any plane, and the equator is a plane, the meridian is also a plane, any plane has two poles. The poles of the equator, of course, the North Pole, way up here in the north, and the South Pole. The Earth rotates around that axis, as you probably already know. So we have the equator, great circle, North Pole and South Pole. We measure then degrees latitude going north, 10, 20, 30, 40, 50, 60, 70, 80, until we get to 90, which would be exactly the North Pole, 90 degrees northern latitude. And if we go south, we're measuring also from 0. The equator is 0 degrees latitude. We measure south, 10, 20, 30, 40, 50, 60, 70, 80, 90, until we get to the South Pole, right? So these are the two ways of, or the ways we measure coordinates. North and south, latitude, east and west, the longitude. Having those two possible coordinates, we can locate any place on Earth. One example of which would be my birthplace, Baltimore, Maryland. If you see in Google Earth, down here you can see the latitude and the longitude. I happen to know the coordinates for Baltimore, where I was born, way back when. It's 39 degrees north and 76 degrees west. So let's see, it's going to be, there we have it. 39, where are we now? 39, 39, 39, and 76, I have to be a little more precise here. 76.6. Where are you, Baltimore? Well, it's somewhere around here. I'll have to get the more exact coordinates, which I don't have in my head. I should. 39, let's see, that'd be 39.17 and 76.6. So I'll have to go a little more over here. Here we go. You can play around with Google Earth and find things. There we go. Born right around here in this area. We'll see that in the second part, because in the second part, what we're going to do is deal with some other great circles that are useful for marking on the Earth exactly where a place is. I'm going to use Baltimore as an example there. Of course, when you get the Omnicycles program, here it is again, you'll be able to do your own natal chart and then convert the data to put into Google Earth. We're going to see exactly how that's done step by step. So you'll be able to see your own place of birth in Google Earth pinpointed with two great circles. You'll be able to see your own planets projected onto the Earth. We'll see that in, well, for me, probably in part 3, I'll probably be doing that. And just so you know, this Omnicycles program and its Google Earth capabilities is now free. So you can download Google Earth for free and also Omnicycles for free. After I say goodbye here, stay tuned. Don't turn the video off yet, because I'll put up the addresses exactly where you can get the Omnicycles program to install it and to use in conjunction with Google Earth. Okay, once again, I'll show you Google Earth. Hope you understood how you measure now longitude and latitude if you didn't already. In the second part, we'll get into more details, and details that are well, a bit more useful for astrology in particular. I bid you farewell, and I wish you a nice day. Bye now, but do stay tuned to see where you can get Omnicycles, so keep this video going to the very end. Okay, bye.